Good evening, guys. So we'll be starting with the discussion of week 4. I hope I am audible to everybody and the screen is also visible to you guys. So I am Rishabh. I am a PhD scholar at IIT Kanpur, and today we'll be discussing the concepts that were being taught in discussion week 4 for biochemistry NPTEL course. Okay. So before starting, one of you guys asked me where are the video links are available. So in the course column itself in the NPTEL website, there is a title named this discussion weeks kind of thing. Yes, so from there you can directly access it. Okay, so starting with the first question. So when K2 is a rate limiting and K2 is very less than K minus 1, so Km becomes equivalent to which of the followings can be correct here? So what can be the correct answer? So did you guys get the question? Okay, so let's discuss this. So in a common enzyme equation that we study, E is the enzyme. Okay, let's see. Okay, so E is the enzyme that is reacting with the substrate. So this is a equilibrium reaction in which Es is formed. Okay, so for the formation of Es, this is the constant, and for dissociation of Es, this is the constant. Okay, now when Es is being converted to product, this forms E plus P. So P is the product here. So this dissociation of enzyme substrate complex to E plus P is has a constant of K2. Okay. So this is a common reaction that we use to derive the Michaelis-Menton's constant basically. Okay. So now when we calculate Km from here, it is the addition of the dissociation constants divided by the association constant, like we calculate the equilibrium constant basically. Okay, so considering this, now there are very variations of this particular equations. Now when K2 is very less than K minus 1, okay, that means K2 is rate limiting. Okay, so the formation of product basically depends upon K2 in which enzyme substrate complex will be broken down to product P. So that is the meaning of the rate limiting step. That means while calculating the equilibrium constant, K2 is the major factor that will be used. But in this case, it is very, very less than K minus 1. Okay, so now what will be the case? When K2 is very, very less than K minus 1, so Km becomes K minus 1 by K1. Okay, so this depicts the dissociation constant of the ES complex with E plus S. So once ES is formed, it can be associated by the constant K1 and dissociated by the constant K minus 1. So if Km is the ratio of K minus 1 to Km, this depicts the dissociation constant of ES. So this dissociation constant is basically depicted by Kd. Okay, so option A is the correct answer here. So when K2 is rate limiting and its value is very, very less than K minus 1. So in that case, Km becomes equivalent to Kd. Okay, so the correct answer is option A. So is the explanation clear? Okay, so let's move forward. Okay, so the second question is the reaction in which ethanol is oxidized to yield acetaldehyde has a standard Gibbs free energy of 3.1 kilocalorie per mole in the absence of the enzyme. This reaction takes place 106 times faster in the presence of the enzyme alcohol dehydrogenase. So estimate the Gibbs free energy of the reaction in the presence of the enzyme. So what can be the correct answer? So any guesses? Okay. So please tell me what does a enzyme do? What is the main function of the enzyme in a chemical reaction? Okay, it decreases the activation energy. Okay, then anything else? Does it affect the rate of the reaction? Yes, it enhances the rate of the reaction. Does it have any effect on the equilibrium? No, right? But it can help in achieving that equilibrium earlier. Okay, so it will not affect the equilibrium state or equilibrium value of that particular reaction, right? So if it is not affecting the equilibrium, that means it will not affect the thermodynamics of the reaction. Okay, so by thermodynamics I mean that the standard Gibbs free energy or the enthalpy of the reaction will not be hampered by the enzyme. Okay, so if the Gibbs free energy of acetaldehyde was 3.1 kilocalorie per mole, so in the absence of the enzyme, and if we add the enzyme, then the Gibbs free energy will remain the same. There will be no difference at all. Okay, because the enzyme does not hamper the thermodynamics of a given reaction. That's the basic uh, concept that we study. So here no change will be there, so the Gibbs free energy would remain the same. That is option number D. Okay, is the explanation clear? Hmm. Okay, so let's move on to the next question. The rate constant of the enzyme E binding to its substrate S is 4 into 10 to the power 7 per second. The rate constant for the dissociation of the ES complex is 7 into 10 to the power 5 per second. The rate constant for the formation of the product P is 9 into 10 to the power 5 per second. Based on this information, choose the correct options. So, what can be the correct answer? Just think and answer. Actually, the question would be incorrect. Okay, so you have to choose the incorrect options. So, any answers or any guesses? Okay, so my suggestion is you just calculate the km and let me know, then we'll discuss. Okay, were you able to calculate the km? Yes. And what would be the kd? Okay, so first we'll calculate the km from the given data. So the rate constant for the enzyme E binding to the substrate S is this. So this is our K1. The rate constant for the dissociation of the ES complex is 7 into 10 to the power 5. This is our K minus 1. Okay. And the rate constant for the formation of the product is, this is our K2. Okay. So as per the formula for Km, it's K minus 1 plus K2 by K1. Okay. So if we calculate like this, then no, sorry, this would be 7 into 10 to the power 5, 4 in 9 into 10 to the power 5, 4 into 10 to the power 7. Okay, so this would roughly come around 0.04. Okay, not 0.0175. Okay, so the Km or the Michaelis-Menten constant for this reaction is 0.04. So the option E is definitely not correct. Now, if we see through other options and if we calculate the Kd, that is K minus 1 by K1, that would come around, 7 into 10 to the power 5 and 4 into 10 to the power 7. Okay, so that would be around 175, I guess. 4 over 10. Yes. So this would come around 0.0175. Now, if like, although the reaction is in steady state every time, that's how we have considered it is in a steady state. So all the things that have kd as 0.04 will definitely go wrong, because in this case the kd comes out to be 0.0175. Okay, so the dissociation constant is 0.04 and this. So these two statements are also incorrect in that case. Now, if we consider Kd as this much, so at that time the reaction is not in steady state basically. Okay, and because it is reaching steady state, so this would be considered as a pre-steady state, not a complete steady state right now. Okay, so when the reaction starts, then the concept of Kd comes into play. So at that time, it would be a pre-steady state rather than achieving a steady state at that time. So in that case, the options A and options C will also go incorrect. Okay. So none of the options in the available list are correct. So the correct answer would be all of the above. So because we have to find the incorrect option. Okay. Okay. So hence the answer is all of the options are incorrect. So is the explanation clear? Okay. So what happens whenever we consider a enzyme reaction? Sorry, E plus P. So in this case, when we can consider this case, okay, first we add the enzyme and the substrate. So in that case, first it will achieve the pre-steady state, in which the enzyme basically is start binding to the product. Okay, so this is considered as a pre-steady state. Once enzyme is start as bound to substrate, and then it is actually a enzyme substrate complex. So to achieve a state in which this enzyme substrate complex is constant. Okay, so the amount of product that is being formed and the amount of enzyme substrate complex that is being achieved right now after the formation of the product. So this remains constant in a steady state. Okay, so after adding enzyme and substrate, we achieve a pre-steady state in which the substrate is actually being bound to the is starting binding to the enzyme. So the concept of dissociation constant comes when we are actually seeing a binding of enzyme to the substrate. Okay, so if we consider KD, so in that case it would be in a pre-steady state rather than being achieving a steady state. And if we say the reaction is in equilibrium, then this is not correct, because in an equilibrium reaction, the ES that is being formed is actually being consumed back to the enzyme substrate also. But here that is not the case. Okay, now is the explanation clear? Okay, so let's move on to the next question. So, glumalase synthesizes mu-galactose by linking one residue of glucose and maltose. For this reaction, the K1 is this, K minus 1 is this, and K2 is this. Given the enzyme catalyzes the formation of 146040 mu-galactose molecules per minute, calculate the specificity constant of the enzyme. So please calculate and let me know. Okay, are you able to calculate or there is any confusion? Okay, let's see. So you are given with K1, K minus 1 and K2. Okay, and this is the Kcat that is given. So this is 106040 per minute. Okay, now we have to calculate the specificity constant, that is Kcat by Km. So for calculating this, we have the Kcat, but we need in minutes. So that would be 16040 by 60. So this would be second inverse. Okay. Now Km will be given by this formula. If we directly substitute the values that are given, so into 10 to the power 4 plus 2 into 10 to the power 5. Oh, sorry. 3 into 10 to the power 3, and this will be 2 into 10 to the power 5. Okay. So from this, first we'll calculate the Km. Okay. So that would come around 11 by, sorry, not 11. This would be 83 by 2. Okay, so this would be the Km value. Now we have to find the specificity constant, that will be Kcat by Km. So we'll just put this and this particular value and we'll get the ratio, and that would come around roughly 586. Okay, so this would be answer A. So I hope the concept is clear that how to calculate. Okay, is it fine? Shall we move forward? Okay. So this is the next question. So delta amino levinic acid synthase catalyzes the formation of delta amino levulinic from glycine and succinyl coenzyme A. Following is the double reciprocal plot for the same. So sorry, this number is not to be needed here. So propyl carbonyl oxyrane 2 carbonyl glutamate inhibits the above reaction. The mechanism of inhibition is given below. So this is the mechanism that is being followed. Okay, based on the above information, choose the statements that correctly defines the outcome of PC2CG addition to the reaction catalyzed by the ALA synthase. So these are the statements given below. So what can be the correct answer? That are basically, these statements are incorrect. So what is actually incorrect in the given statements? B, C, D, E incorrect. Okay. Any more answers? Okay. So the correct answer is A, B, C, D are incorrect, and the E option is correct. That means it can be the correct explanation. Okay. So how we'll see. So first, as the reaction state kinetics is reaction is mentioned here, that means the enzyme, sorry, the inhibitor basically affects when the enzyme bound to the substrate is converted to the like intermediate E prime P1. Okay, so that can be considered as a intermediate. Okay, so in that case, it has no link for to be a competitive inhibition. Okay, because in case of a competitive inhibition, it will directly affect the ES1. Okay, so it will not be able to sorry, it will not be a competitive inhibitor, right? Now if we see that it is directly bounding, it is directly binding to the, yeah, so it is directly binding to the E prime P1, that is an intermediate. Okay, so in that case it is nearly a, sorry, it will not be in the uh, uncompetitive also. Okay, so now if we see the double reciprocal plot of this particular uh, enzyme kinetics, so in that case we can see that the V max is not changing, right? And the Km is basically being affected by the glycine concentrations at different glycine concentrations that we are using. Okay, and here we have not, they have not mentioned about the inhibitor that they have used, right? So that means it is not at all affecting the enzyme kinetics at this point, being the binding of enzyme and the substrate, right? So in that case, V naught will actually not be affected, V max will not be affected, because here it is the first substrate and it is being bound to the first intermediate that is being formed. Okay, now similarly the Km will also depend upon the uh, rate constant for the first substrate followed by the rate constant for the second substrate, so it will also be not affected by the particular inhibitor. Okay, so the correct option would be all the three, okay, will not be affected at all by the addition of the inhibitor, although Km has some role here, but it will not be affected because the binding of the substrate, to the enzyme will not be affected here. Okay, so all the four options are incorrect. Okay, which point did you not understand? Okay, so here, as we can see in the graph, okay, it's the different glycine concentrations that are being used. Okay, so glycine is basically a substrate here. Okay, just 1 minute. So here glycine is a substrate, but here varying the substrate concentration is not actually varying the substrate concentration is actually varying the Km, but it is not because of the inhibitor, because we are using different glycine concentrations here. Okay, so that's why the Km value that is being changed is due to the different substrate concentrations, not the inhibitor. So Km will not be affected here. Similar is the case with the V naught value, that is a rate. So rate will be subject to the substrate concentration, not the inhibitor here. So both V naught and Km will not be affected. And as we can see, the Vmax is almost the same. It's the same because every line is passing through one common point. So it's not changing. So Vmax will also remains the same. Just simple explanation based on the graph that is being given. So is it fine? Okay. So let's move on to the next question. Identify the correct statements regarding enzymes. So what can be the correct answer? Okay. So the first statement states that for a competitive inhibitor, when the enzyme is saturated with the substrate and the S to I ratio is 7 is to 2, the Vmax remains unchanged. So in that case, yes, we have to take the substrate in higher concentration as compared to the inhibitor, and In the same case, we can see that the Km is actually increased and the Vmax remains the same. So the first statement is correct. The second statement is when K2 is rate limiting, Km is equal to Kd. This we have discussed in the last few questions also. So this is also correct. For a reaction where K1 is equal to zero point 0.2, K2 is equal to zero point 0.02 and K minus 1 is zero point 0.001, Km may refer to the enzyme affinity for a substrate. In this case, when Km is referred to as the enzyme affinity, in that case K minus 1 must be very very greater than K2. Okay, so then the enzyme affinity can be enzyme affinity can be actually represented by Km. Okay, but here if we can see that it is not very much in greater than K2, so this statement is false. Uncompetitive inhibitors impede the reaction by terminally binding to the ES complex. No, this is not a correct statement. Uncompetitive inhibitors may increase the Km as the substrate required to reach a certain level by Vmax increases. No, this is also not correct because both Km and Vmax are reduced in case of uncompetitive inhibitor reaction. Okay, so the correct answer is A and B are the correct statements. The rest of these statements are false. Okay, so let's move on to the next question. Identify the correct statements regarding enzymes. So the first statement is the specific activity of the enzyme increases with an increase in Km. So no, this is not a correct statement. The specific activity of the enzyme actually does not depend upon the Km. Okay, so it doesn't have any dependence on the Km, so it will not increase or decrease with the increase or decrease in Km. The competitive inhibition cause a decrease in Km by binding to the active site of the enzyme. Yes, this is correct. No, this is not correct. Although competitive inhibitors bind to the active site of the enzyme, but this leads to increase in Km, not decrease. Okay, so this is also false. Km, the affinity of the enzyme for its substrate, is lowered upon the addition of a non-competitive inhibitor. No, this is also not correct. Okay, because in case of a non-competitive inhibitor, the uh, Km is actually not changed. Only the Vmax is actually reduced. Okay. In general acid-base catalysis, the side chain of amino acids in the enzyme act as an acceptor or donor of protons. Yes, this is correct because all the basic and acidic amino acids actually play a role in acid-base catalysis of the enzyme. The energy released upon the increase in entropy aids in enzyme catalysis. No, this is also false because as we have seen earlier that there is no change in the thermodynamic parameters during an enzyme reaction. Okay, for suicide inhibitors there is a decrease in Km alone. No, this is false. And for suicide inhibitors there is decrease in Km and Vmax. This is also false. So the correct answer is option D alone. Okay. So let's move on to the next question. Phenylalanine ammonia ligase catalyzes the formation of 181800 molecules of 4-cameryl coenzyme A from phenylalanine permanent. So this is given as the KCAT. Yes, this is the KCAT molecules per minute. Okay, so this is the efficiency of the enzyme. Now we have to take out the time taken by the enzyme to leave the single phenylalanine molecule. That means we have to calculate the turnover number, and turnover number is given by 1 upon kcat. That is the reciprocal of the kcat. So if we calculate this much, so this comes on around to be 5.5 into 10 to the power minus 6 minutes. Okay, so the correct answer is option number A. Okay. So let's move on to the next question. Which of the following statements regarding saccharides are false? So serum antibodies are glycoproteins where the carbohydrate moiety consists of a repeating unit of alpha D glucose, alpha D galactose, and alpha D mannose. So yes, this is a correct statement. Okay. Then we have the alpha D glucose, 1 alpha D glucose serves as a circulatory sugar in insects. Yes, this is correct, and this sugar is called as trehalose. Okay, the sulfolated glycosamine hyaluronate is a key component of the synovial fluid. No, this is false. And chitin is a polymer of N-acetyl glucosamine joined by the beta 1,4 linkages. Yes, this is correct. So the correct answer is option A and C. So option A is false actually. Okay. So let's move on to the next question. For an enzyme, K1 is 4 into 10 to the power 3, K minus 1 is 2 into 10 to the power 3, and K2 is 3 into 10 to the power 2. The total enzyme available ET is 10 to the power minus 4 molar. Calculate the Vmax. So for Vmax, we need Kcat and ET. Okay. So this is what we need for calculation of Vmax. And in a general enzyme substrate reaction that we see in steady state, this is the enzyme substrate that forms a complex enzyme substrate complex which further converts to enzyme and product. So this is K1, this is K minus 1, and this is K2. So K2 is actually referred to as Kcat, that is actually the rate constant for the formation of product. Okay, so here K2 that is there is actually Kcat. So we can calculate Vmax now directly. So this will be 10 to the power 2 and this will be 10 to the power minus 4. Okay, more. So now if we directly multiply, this will be 10 to the power minus 2 mole per second. Okay, so the correct answer would be option number B. Okay, so let's move on to the next question. Which of the following statements regarding lipids are correct? So cis 9 hexadeconic acid contains a cis unsaturation at the 16th carbon. No, this is false. The saturation is present actually at the ninth position as mentioned in the name itself. So this is false. A fatty acid with a double bond configuration of cis 9 to delta 912 is known as non-ecodonic acid in the IUPAC system. So no, this is actually a saturated fatty acid. Okay, so saturated fatty acid is the one which do not have any double bonds. So that's why it is a saturated fatty acid. So it will not have any double bond in its IUPAC name. Acyl isomerase is responsible for the conversion of trans fatty acid to cis fatty acid. Okay, so no, this is not the case. Actually, acyl isomerase refers to the change of fatty acid molecules from one to another in a beta oxidation of the fatty acid. So this is not the correct answer. The highly reduced nature of fatty acid make them high energy yielding molecules. Yes, this is correct because because fats actually yield more energy, even more than the carbohydrates, but they are the molecules that are being used for energy yielding the last. Okay, so although this is the correct molecule, mono di and triacyl glycerol form bilayer when they added to aqueous environment. No, these do not form bilayer. Phospholipid form bilayer because these three are actually hydrophobic molecules. They are not hydro amphipathic molecules basically. C2 double bond, C3 double bond in archibacterial ether lipids provide resistance to extreme conditions. No, this is also not correct. So the correct answer is option number D. Okay, so that is the correct statement basically. The specificity constant of a reaction in which Kn is much greater than the substrate concentration is 10 to the power 6 molar inverse. second inverse. The total enzyme concentration is given as this, and the substrate concentration is 1 millimolar. So the initial velocity we have to find. Okay, so in this type of question, first we have to find out V naught. So for the first we will check what are the conditions that are given. First is the specificity constant is 10 to the power 6 mole inverse second inverse when the Km is much greater than the substrate concentration. Okay, so this is the first condition that is given. We have the total enzyme concentration as 2.5 micromolar and the initial substrate concentration is 1 millimolar. Okay, so first we'll see that the Km is equal to, sorry, V naught by the Michaelis-Menten equation we have V naught is equal to uh, V max into S by Km plus S. Okay, so now as we can see that Km is very greater than S, so that means this S will be neglected here, and for V max we have the specificity constant that is K cat by Km. Okay, so now K cat will be equal to specificity constant into Km. Okay, so now if we substitute here, that means V naught is equal to, and V max is basically given by K cat into enzyme concentration, total enzyme concentration. Okay, so K cat will be specificity constant into Km, and here Et into S divided by Km. So this will cancel out. Now if we put the values, this will be 10 to the power 6. Et is 2.5 into 10 to the power minus 6 molar, and substrate concentration is 10 to the power minus 3 molar. So if we calculate, this comes up to be 2.5 into 10 to the power minus 3 molar second inverse. Okay, so the correct answer is option number B. So the next question states that the we have to match the following in context of the Lineweaver-Burke plot and select the correct option. Okay, so the basic Lineweaver-Burke plot that we plot, so this is actually 1 upon V naught, this is 1 upon substrate concentration, the slope of the line is Km by V max, this point is 1 by V max, and this point is minus 1 by K. Okay, so this is how a normal Lineweaver-Burke plot is actually plotted. So now in case of a competitive inhibition, we know that Km is actually increased and Vmax remains unchanged. Okay, so in that case, the slope of the equation will be increased. So this is the slope of the inhibition, and then the Vmax remains the same. That means the Vmax will be 1 by Vmax. Okay, so A will be 2 and 2. So A will be 2 and 3. Sorry, 2 and 3. So this would be the correct answer. Then in case of uncompetitive inhibition, both Km and Vmax are reduced. Okay. So in that case, if Km is both will be reduced, then the slope will remain the same, and Vmax is also reduced, so this will be the correct way of representing the intercept. So this would be B1 and 1. Okay, so this B1 and 1. Then in case of a mixed inhibition, if we see the Km remains the same but Vmax is actually reduced. Okay, so if Km is remaining the same and Vmax is reduced, that means this would be the slope, and Vmax is actually reduced, so this would be the slope intercept. Okay, so in case of C, it will be second and then 1. Okay, so like this. Then for no inhibition, it will be Km for the slope if there is no inhibition, and Vmax for the y-intercept. Okay, so the correct answer is option number C. Okay, so let's move on to the next question. Select the correct option that reflects whether the following statements are true. Suicide inactivators are typically converted into very reactive compounds. Yes, this is correct. Then the turnover number cannot be the same for two reactions with different uncatalyzed rates. So yes, this actually is false, because the turnover number can be same for two reactions which have different uncatalyzed rates. Okay, there is no relationship between the degree of inhibition and substrate concentration of for mixed inhibitors. Yes, because it does not depend upon the Km or the substrate concentration. Hence, Km is actually have no effect here. Okay. Uncompetitive inhibitors lead to no change in Vmax. No, in this case, Vmax is also decreased. Okay. Competitive inhibitors lower Vmax. No, in this case, Vmax is actually unchanged. It doesn't have any effect on the Vmax. Okay. So here the true statements are option number A and option number C. Okay. So let's move on to the next question. Diflubenzuron, an insecticide, belongs to a class of molecules called acyl-ureas. Many of these molecules have been found to be potent inhibitors of an enzyme. They harm insect pests but not the crops. Which of the following enzymes might these molecules be inhibiting? So, as we can see, that the insects have a outer covering, so that is made up of chitin. Okay, so any of the compounds that we use for like inhibiting the insect generation, then we directly inhibit the formation of the chitin. So in short, the formation of the chitin actually takes place with the enzyme called as chitin synthase. Okay, so if we inhibit this particular enzyme, then chitin will not be formed, and hence the outer covering of the insect is not formed. So it not it makes the insects vulnerable to the predators and the outside environment. Okay, so it will actually inhibit the chitin synthase enzyme. So the correct answer is option number B. Okay, so let's move on to the next question. The given figure represents the structure of glucosaminoglycan subunit used to answer the following questions. So here are different parts that are labeled. So just based on the positioning of the label, you have to just tell which glucosamine glycan is actually being represented here in the figure. So this is actually a misprint here. Okay, so that cannot be represented by the figure that is given here. Okay, so in the figure, as you can see, this F region, so this is basically first carbon and this is the third carbon. So there is beta 1,3 linkage between the heteropolysaccharides. Okay, and that is actually found in chondroitin 4 sulfate and hyaluronate. Okay, so the other two, heparin and keratin sulfate, do not have this linkage. Okay, so these compounds actually do not cannot be represented by this particular image. Okay, moving on to the second question. Given that the following compound is present in the vitreous humor of the eye, match the following. So the vitreous humor in the eye contains a compound called as hyaluronate. Okay, so in that case, the so if we see the structure of hyaluronate, then B represents OH, C represents H, then E represents NHC double bond OCH3, G represents the beta 1,4 linkage, and this whole structure forms the N-acetyl glucosamine. Okay, so after matching these, the correct answer turns out to be option number D. Okay. Hmm. Okay, so if A turns out to be CH2OH, so that means if A we turn to CH2OH, so in that case this whole structure, that is H, becomes glucose. So the correct answer is option number C, that is glucose. Okay, because here in this position this will be the fifth carbon that is attached to the sixth carbon, that is CH2. So this turns out to be glucose. Okay, so let's move on to next question. If the figure represents the component that makes up the walls of the aorta. Okay, so which of the following can be the correct option? So the walls of the aorta are actually made up of chondroitin sulfate. Okay, so now look upon the structure of this particular thing. So in that case, in chondroitin sulfate, A turns out to be COOH. So H turns out to be beta glucouronic acid. Okay, then F turns out to be a O bond between 1 and 3. Then B turns out to be H, C turns out to be SO3H, then D turns out to be CH2OH, E turns out to be NH, C double bond CH3, and this linkage will also be beta 1 3. Okay, now sorry, beta 1 4, and this whole structure will turn out to be N acetyl beta galactosamine 4 sulfate. Okay, so now let's look upon the option. So A is CO negative, B will be H. So this turns out to be wrong. Then B turns out to be H. Okay, C turns out to be SO3 SO4 negative. Then F turns out to be beta 1 3. That is fine. Then G turns out to be beta 1 4. No, this is false. Okay. Then oh sorry, this is correct because G turns out to be beta 1 4. Okay. Now let's see option C. That is, it's C is sulfate, correct. A is COH, H is glucouronic acid, and I is N-acetyl glucosamine. So no, this is galactosamine. Then D is CH2OH, correct. E is OH. No, this is false. Then H is glucosamine. No, this is also false. This is correct. So the correct answer is option number B. Okay, so let's move on to the next question. How many of the following statements are true? Sucrose can exist in two anomeric forms. No, this is false because sucrose cannot exist in two forms because its anomeric carbon is not free for rotation. Proteins are the major constituents in the proteoglycans. Okay, so no, because here we are talking about the carbohydrates. So, carbohydrate or the glycan part will be more as compared to proteins. Melting point of saturated fatty acids increases with increase in carbon number. So, yes, this is correct because as we see, if the carbon number increases, the melting point of the saturated fatty acid increases. Lectins are proteins that recognize specific sugar molecules to mediate several biological processes. Yes, this is also correct because they recognize specific sugar molecules to mediate the biological processes. So the correct answer is C and D. These two statements are true. Okay, so this leads to the end of the lecture. Let's meet in the next class. Thank you guys for joining.